Hey everyone, welcome to Solving Right Triangles. We're actually working in our Springboard book today. We're on page 315. So if you don't have your book, hit pause and go get it. And you're also going to need your calculator, so grab that as well. If you look at the learning targets, you can see that we are going to be using our trig ratios, calculate angle measures from trigonometric ratios, and solve right triangles. So some new methods today to solve right triangles, and you'll see they're pretty helpful because it goes beyond the scope of what Pythagorean theorem could have done for us before. So we're just going to investigate this together. Number one, it says in a right triangle ABC with acute angle A, you know that sine of A equals square root of 3 over 2. Draw a possible right triangle. All right, so what could that look like? They're just asking you for the possibilities. And so just draw a right triangle. It doesn't really matter what it looks like at this point. But we know acute angle A, so it'd be A, let's go BC this direction. And we know that sine of A, right, would be the opposite over the hypotenuse. So this would be the square root of 3 over 2. And you might be looking at that and saying, hey, I know those, right? If this is the square root of 3 and this is 2, this side AB should be what? Hopefully you said AB should equal 1. This is definitely our 30, 60, 90 triangle. You should recognize that. So angle A would be how big? Yes, hopefully you said angle A would be the 60 degrees, right? Because it's opposite the square root of 3. So we're going to use this idea to work out, so we could find that the measure of angle A equals 60 degrees. Oh, so that was part B, sorry. I jump ahead in the Springboard stuff. But that's using our special 30, 60, 90 right triangles, that the measure of angle A is equal to 60. And so on the same token, we might know that if they told us that the cosine of A was 1/2, right? We would know that would be the same thing. Alrighty, so we're going to look at this idea of knowing the ratio of a trig function to be able to figure out the angle measure. And we know two special triangles, your calculator is stock full of more relationships, and that's why we have the calculator today. So if you take a look down here, it's telling you about inverse trig functions. And we denote the inverse trig function by this little -1 here. That's how you know it's an inverse. But we're going to be looking at the inverse of the ratio, and that is going to provide us with the angle measurement. So here's what the rule is down here. If we have the sine of angle A equals x, then the inverse of x, which is the ratio, is going to give you the angle. So when we take the inverse of the trig ratio, it's going to provide us with the angle measurement. We're going to do this first in our calculator. These first problems, though, you should be able to answer, right? When you look at this and look back at the triangle up at here top, we've got the inverse of 1/2. So sine is 1 over 2. So if we're doing 1 over 2, that's your 30-degree angle. And let's go test that out. And then we'll do the cosine. Let's go test that on the calculator first. Sorry, I'm getting ahead of myself. Okay, so grab your calculator. If you are using a calculator like mine that is newer, so either a graphing calculator or you have the solar panel, it's going to work the same way mine is. And here's what you're going to put into it for letter A. Let me get this up here so you can see this. All right, so this time we're going to be using the inverse function, and some calculators come in a little bit different way. Mine is a double press on the sine function. So I just press it twice, and you notice it gives you the inverse sign. Some of you have highlighted. See how my keys are highlighted in blue? That's the second function of your key. And a lot of your calculators are going to be like that, where the inverse function is going to be directly above the original sine function. And so you have to use this second button, or it might, what else could it say? I don't know. Mine's the second button, the second function, to get the -1 on your trig function. All right, so I'm just going to put in here the 1/2, and you could put it in as 0.5, or you could do 1 divided by 2. And you see it gives me the 30 degrees. So pretty nifty. Now we know that the cosine of 1/2 is looking at the adjacent side over the hypotenuse. So if we go back to our triangle up here, the adjacent side would be to the 60 degrees, right, over the hypotenuse. So the cosine, the inverse sine of 1/2 is 60 degrees. And this happens with sine and cosine, because you remember in the triangle, these are your complementary angles. And so they have the same ratio for the opposite trig functions, right? Okay, so the rest of them, we're gonna grab our calculator and work on our calculators. So we'll do tangent of 1/2, and that's not on our, I'm gonna do one more and I'll let you finish off the rest of them. All right, so for tangent of 1/2, goodness gracious, Mrs. Moore. We're gonna do inverse tan, and this time I'll do it as 1 divided by 2 so you can see that it works the same way. And you get a very small number, and it says to round to the nearest tenth. That doesn't even have a tenth, does it? Oh, I did tangent. Look at that. Look at my thing. I didn't do it right. Clear. Sorry. Double click. 1 divided by 2. Oh, there we are. Round to the nearest tenth. So 26.6. And this is degrees, right? We're getting the angle measurement. All right. I'm going to give you a few moments. Try this out on your calculator for D, E, and F, and we'll come back and look at the answers. If your calculator is older, if you have the TI-30 or you have a Casio, that is going to work backwards from what we're doing. So you're going to put in the 1/2 and then hit inverse tan. You're going to do the reverse of what we're doing, and you should get the 26.6. Okay, let's take a look at our answers for D. I'm just going to write them out for you. D is 48.6 degrees. E is 41.4 degrees. And F is 36.9. Okay, hope you did okay. Just pressing buttons on your calculator. Nothing too big. All right, so now we're going to take this idea and use it to actually solve some right triangles. So go to our next page. And here we go up at the top. Trisha designs the logos shown for one of her clients. She needs to know all of the missing dimensions and angle measures of the logo. So here's her logo over here. Of course, it's a right triangle. How funny. So it says use inverse trig functions to find the measure of angle Q. So when you look at angle Q, you are given the 65 meters, which is opposite, and you are given the 33 millimeters, which is adjacent. So which trig function are we going to work with to find angle Q? Hopefully you're saying tangent. That's right, because we're going to do the inverse tangent of the opposite side over the adjacent side. So we're going to put that in of 65 millimeters over 33 millimeters. And the millimeters are going to cancel because remember, 1 a degree measure, so you're not going to have the millimeters anymore. And then just grab your calculator. Here we go, handy dandy calculator time. We're going to do inverse tangent. Make sure you hit that button. We can do 65 divided by 33, close the parentheses, and we've got 60, and it says round. Let's just round it up to the nearest angle, right? So the nearest angle measurement would just be 63 degrees. All right, and then number 4, it says describe 2 ways to find the measure of angle R without finding the length of the hypotenuse. All right, so well, if we know if Q is 63, I hope, oh my goodness, in honors geometry, you should be able to subtract that from 90 and get your 27, maybe. But let's do it with a trig function just to practice. So which trig function would we be using to find the measurement of angle R? Hopefully you said inverse of tangent again, because you'd be exactly right. So inverse tangent, but this time we're going to switch, right, the opposite and the adjacent, because now we're looking at angle R. And so the 65 millimeters is going to change to our adjacent side, and the 33 millimeters will now be our opposite side. So it would look like this. Inverse tangent, we'll do the opposite side, the 33. Why did I put an equal sign there? The 33 millimeters over the 65 millimeters. And the millimeters will cancel. So we're going to do inverse tangent of 33 divided by 65. All right, and look at that, 26.9, which rounds up to 27. We already knew that because we know 90 minus 63 gives you 27. So 2 different ways that you have to work with that. We just wanted to practice our trig function. Okay, so now number 5, it says describe 2 ways to find the length of the hypotenuse. So, oh my goodness, number 1 way, which you've done already, would be how? How have we find the length of hypotenuse in the past? Hopefully you're telling me c squared equals a squared plus b squared, which is our Pythagorean theorem. But we're not going to do that today. We are going to practice using our trig functions. So how could we use our trig functions? Well, let's decide on an angle measurement to work with. It doesn't make a difference. Why don't we go ahead and just use the measurement of angle R as 63 degrees. So we'll focus on angle R. And then we are given the 33 and the 65. So again, we are working with tangent, right? Now we're not going to use the inverse this time because inverse is just when you're finding the angle. We're going to go ahead and use our tangent function. So the tangent of an angle equals the opposite over the adjacent. Alrighty, so we've got the tangent of 63 degrees, and from angle R, that's our 63 degrees. The opposite side is 33, and the adjacent side is 65. And we've been doing this a lot. We're going to make a proportion. Oops, Mrs. McGuire, I messed up. Okay, guess we're not using tangent if we want to find QR, are we? Nope, we better back it up and use which trig function, guys? Well, we could use cosine or we could use sine, couldn't we? Because we have both the opposite and the adjacent side. So I'm going to get rid of this. It's okay to make a mistake. It happens. I'm going to go ahead and use sine. Sine theta equals my opposite side over my hypotenuse, QR. So we're going to stick with angle R, sine of the 60. It's 27 degrees, guys. Wow, Mrs. McGuire. I need help today. Okay. Oh boy, I shouldn't be doing videos this late. Okay, so sine of 27 degrees equals the opposite side, the 33 over QR. All right, so cross products. We have QR times sine of 27 degrees equals 1 times 33. All right, so we did one like this the other day. We're solving for QR. We're going to go ahead and just divide by the sine of 27. All righty, so in your calculator, to get our final answer for QR, we're going to do 33 divided by the sine of 27. I'm going to come over here with the calculator. 33 divided by the sine of 27. All right, and we get 72.68. You know what? I'm double checking myself. Whew, it's been a rough day. Yes, 72.7. All right, my dears. There you have it, solving right triangles using inverse trig functions and trig functions. I am assigning you homework, and it's basically problems down here. So go online, you can do your work here, and then put your answers into the assessment that I'll give you. All right, have a great day.